Hello everyone. In this Labtube, I will solve an example of a form of questions which I receive a lot of comments about. Let's see what is the question. Question asks to find a standard form of a line in R2 which is perpendicular to a given line and passes through the origin. The source of the confusion for questions like this goes back to the fact that only in R2 we have standard form for line as well as point parallel. Compared to higher dimensions, in R3 we have standard form for planes, point parallel for lines. In Rm, we have standard form or point normal form for hyperplanes, point parallel form for lines. So, but in R2, these two forms, you have both of them for lines. And that's the starting point. You have to know how to go from a normal vector to parallel vector and other way around. So then let me write fact 1. It is related how normal and parallel vectors of a line in R2 are related. So if I denote parallel vector by B, normal vector by N, to go from one to other one, I have to do this operation. Flip the components, switch one of the signs. So if I have AB, I make a new vectors BA, switch the components, change one of the signs. Okay, this is not only works this way. If I have parallel vector, I can get normal vector doing this. It also works the other way. If you have normal vector, you can get parallel vector by doing this. That's fact 1 you have to know. Fact 2 is related to how normal and parallel vectors of two lines in R2 are related. Well, not two random lines. They should have a relation. And for this course, the important relations are they are either perpendicular or they are parallel. So I have two situations. When line 1 is perpendicular to line 2, or line 1 is parallel to line 2. If line 1 is perpendicular to line 2, then normal vector of line 1 is a parallel vector of line 2, and parallel vector of line 1 is normal vector of line 2. And for parallel lines case, in that case, it's easier. Normal of the first one is the normal of the second one. Parallel of the first one is parallel of the second one. So these two facts, you have to know them by heart. And you have to use them whenever you need them. So this is, again, this happens only in R2. And let's see how we can apply these two facts here. First of all, I will call this line L1. So L1 is 2x minus 3y equals to 1. It is given in standard form. When equation is in standard form, you can find normal vector easily. Normal vector of line 1, I will denote it by n1, and it is given by just put the coefficients here. Coefficients of x in the first component, coefficient of y in the second component. And now we are looking for a standard form for L2, which is a line perpendicular to this one, and it passes through origin. And we are looking for standard form equation. That means to find standard form equation, I need normal vector and a point. Normal vector for line 2, I will denote it by n2, and the point with p, in this case, it is origin. Origin is 0, 0. So I have to now find n2. I know that L1 is perpendicular to L2. That means that normal of the second one is equal to parallel of the first one. I'm using this fact. Normal of the second one is equal to parallel of the first one, because they're perpendicular. That means I need parallel vector of the first line. I have normal vector. How can I get parallel vector? This is how you can do that. Flip the components, change one of the variables, one of the signs. So V1 is going to switch them, so -3, 2, change one of the signs. I'll change the first one, 3, 2. So now I have parallel vector of the first one, and by this fact, then I know that I have normal for this. So I write it here, 3, 2. From now on, it's easy. I have normal, I have a point, I can form standard form by n dot x equals to n dot p. N in this case is 3, 2 dot x, y, and it is 3, 2 dot 0, 0. Dot product, just 3 times x plus 2 times y equals 3 times 0 is 0 plus 2 times 0 is 0, so it is 0. Okay, very quick wrap up. In R2, you have to know these two facts. And as I mentioned, R2 is only case in which lines has both standard and point parallel form. That's why you have to know how to switch between normal and parallel vectors. And you have to know what is the relation between normal and parallel vectors of two lines when they are perpendicular or when they are parallel. I will do more examples of this form, and please watch other related videos.